The amount of money in a bank account can be expressed by the following exponential equation, where A is the amount of dollars and T is the time in terms of years. How many years will it take for this amount to be more than 860? So this amount has to be greater than 860. So let's write that down. This amount has to be more than, it has to be greater than, the alligator mouth or Peppa mouth has to be more than 860. Okay, let's go about solving this. Let's start first by dividing by 200. Okay, when I divide these two on a calculator, I end up with 4.3. Now I want to eventually, move this up, I want to eventually isolate that t. So how do I isolate the t? Well, I need to remove this amount. So I'm going to do log and log. Remember, the reason we learn logs is so that when you're solving for a variable in the exponent position, we use logs in order to complete that process. So I want to get rid of this. I write everything down that was already there. On the right hand side, the 1 times 12t. T is in terms of time in years. And now over here, I'm going to approximate this value. Notice that 1 times t is, 12 times t is, I'm saying this wrong, 1 times 12 is 12, and then we have the t. So I know when I finally get an answer here, I need to divide this amount by 12 in order to isolate the t. And we'll have to see what does that really mean. So let's figure this out. I'm grabbing a calculator, and I'm starting at the back. Log of 4.3, enter, divided by log of 1.006. That's this quantity. Now I still need to divide it by 12. And I divided it there by 12, and I get 20 point, well, let's round to the nearest tenth, 20.3. Let's talk about what does this mean. Okay, so this is in terms of years. It says that in the word problem. So the 20.0 would be exactly 20 years, right? 20.9 would be almost 21 years. So this is just a little bit more than 20 years. So it'll take just a little bit more than 20 years before your count to be more than $860. It will take a little bit more than 20.3 years before your count will be more than $860.